Starting off today with the Pig in the Hat English-style ale with tropical teas from Handsome Lad Brewery. Never heard of them, but apparently they're here in Winnipeg. And it says absolutely nothing else about it on the can, so I'll just have to taste it for myself, I guess. It's interesting, almost fruity or something. Strange. So do you remember these little voltmeters that I picked up a few weeks ago in a mailbag, maybe a month ago now? I figured I would take a closer look and just see what makes them tick. So the actual voltage right now is 124.4 volts. And as you can see there, this one over here, what is that one? The yellow one is pretty much bang on. These three in the middle are 4 volts out, and this guy is a volt low or thereabouts. And as we found in the unboxing in the mailbag video, it says on them that they start at 60 volts, and they kind of do, but they're really, really dim down there. But I don't know, they work. They're close enough. They're obviously not precision test instruments, but just for an indicator that you're in the ballpark, that's probably good enough. But when I was messing with them the first time around, I noticed that if you pull the lens off, well, first of all, the LEDs inside are the same color as the lens, but I noticed that this is really loose and wiggly, which got me to thinking, that'd be easy to take apart. I wonder what's inside. So that is what's happening today. So let's see what this one is. Seeing I've already got it partially apart. That little plastic protector just pops off. And it comes off a lot easier than you'd like. When I was screwing the wires onto the back of all of them, a couple of them came off and I had to jam them back in. So there's this retaining ring on the back here. Makes sense. So kind of a rubbery little ring there, gasket I suppose. Not going to mess with that. Then down in here, looks like the screw terminal just goes out to some metal on both sides, which disappears down inside. See what happens if we take the screws right out. I'm not sure how these will come apart, quite honestly. And I think I might have to sacrifice one of these things to the gods of knowledge. But we shall see. So it looks like that little metal bit folds up there. And does this one do the same thing? Okay. So those seem to be the conductors that go down into the bottom of it. Just going to straighten those guys up like that. And that is just the threaded bit that the screw goes into. Right. This one's got a resistor soldered onto it. This one looks like it's got a capacitor. So are we just a capacitive dropper in there? Just flatten out these little bits of stamped metal here so that they will drop down through the holes. I think that's the play. And there it is. So what have we got? Coming off the one side, we have a capacitor with a resistor. The other side, we have a resistor. Obvious things on the circuit board. We have a 10 volt, 30 microfarad capacitor. Big capacitor, 474. Just checking on my reference sheet because I don't have capacitor codes memorized because I don't have to deal with them that often. 474 capacitor is a 470 nanofarad. The resistor that's in series coming in, it looks like it's about a 50 ohm resistor. I wonder if I can measure that one. I don't know if I can, but we'll see. It says it's a 427K. Does that make sense? Got a little diode on there. So that's going to be some rectification, I guess, for a power supply. Probably. Oh, there's a little MELF diode in there too. Okay. Wonder why two different kinds of diodes. The trick's going to be figuring out what this chip is, and the more I look at it, the more I don't see any markings on it. Ya buggers. And then 6 pins going through to the LED. I'm going to see if I can get closer to this and reverse engineer it Big Clive style. I'm not sure how well I'm going to succeed, but I'll give it a shot. Well, that took a little bit of time, but the part that was hard to figure out wasn't what I thought. So let's take a look at this circuit here. Still couldn't identify what the chip is, but that really doesn't matter. I'm guessing it's some kind of a microcontroller, and I'll let you know why in a second. So coming in from the AC line, we have a 50 ohm resistor on this side, and on the other leg we have a 470 nanofarad capacitor and a 430k ohm resistor. After the 50 ohm resistor on this side, it goes into pin 14 of the IC. It also goes through this little voltage divider here to pin 9, and then back over to this guy. That's that leg. In here, we have a Zener diode, a 2.2 volt Zener diode. We have just a straight up diode. We have that electrolytic capacitor. What was it? I forgot to write it down. 10 volt 30 microfarad. So there's that 10 volt 30 microfarad capacitor, electrolytic, and a straight up diode, and that feeds to pin 1. So that is the power supply. Pin 1 is feeding the power supply, and now then, I'm not sure which one of those is measuring the voltage and which one is the return side of the power supply. I'm going to guess it's that one is the return side of the power supply across that capacitor. That makes sense, doesn't it? Yeah, sure. So that's just a super basic, really rough and ready little power supply. The magic, I'm guessing, is happening inside the chip, which is going to be a microcontroller of some kind. And the reason I'm convinced that it is because of how it drives the LEDs. Remember, we have 3 7-segment LEDs, so that's 21 LEDs, 22, 23 for the decimal places, and 24 if you want to light up the voltage sign, and I'm pretty sure it does, if I remember correctly. But on the back, there's only 6 pins. That was a bit of a head scratcher for a minute, until I remembered that Charlie plexing is a thing. So then I started throwing voltage at these, just like 3 volts currently to 20 amps, plus and minus, and I went and did a little bit of Wikipediaing, and yeah, for Charlie plexing, with 6 pins, that can give you up to 30 LEDs. You remember we talked about Charlie plexing a while back, right? Basically, it uses the GPIO pins of a microcontroller in a tri-state mode. So normal binary is, high or low voltage or no voltage, right? But there is a third state which is not connected, like at all. In a microcontroller and an Arduino, you set the pin as an input. It's high impedance. It doesn't have a current path, or at least not enough of a current path to either ground or to positive voltage. And then you set up the LEDs like this in sets like that, and a whole bunch of them. So with that, you can, if you put positive voltage over there and negative voltage over there, that one goes on. If you reverse it, that one goes on. And if you have one or both of them not connected in that high impedance state, then neither of them goes on. That'd be easier if it was in focus. So then you put more LEDs in, and those ones connect there, those ones connect there. So now then, if you have positive voltage there and negative voltage there, same thing happens. And then you can also put another set like that. So now with 3 pins, you can control 6 LEDs, and you can keep going on. So when you start adding beyond 3 pins, it goes up really quickly. And as I said, with 6 pins, you can control 30 LEDs. And that's what's going on here. It's an interesting little circuit to take apart. I guess I kind of knew that there was going to be a microcontroller in there. I wish I could have found a number on it to find out what exactly it is. Odds are it's a purpose designed microcontroller that will do voltage measurement. So what could I do to modify this thing? I suppose I could give it an independent power supply across probably pins 1 and 14. Give it, 3.5 or 4 volts or something like that across there. I don't know whether I'd want to do that or not. It's interesting. But then I should be able to get it to measure a lot lower. Probably. Suppose I could also change the power supply capacitor, this guy here, so that this circuit would get up above its threshold a little bit sooner to power the thing. But that might put too much current through the Zener and make it go kaboom, so that might not be the best choice. Or I could do what I was going to do in the first place and wait for some other possible voltmeters to come in that I've ordered and see if they fit my need any better. Regardless, it was interesting to dig into this thing and just see how it works. I always like to get curious and figure out, and this is how you'll learn. Anyway, questions and comments down below in the comment section. Thanks for watching, everybody. Hope you found that interesting. I will talk to you later.